The focus on this video will be negative exponents and the negative exponent property. The major idea here is if any exponent is negative, we have to make an adjustment to that term. The base must move from the numerator to denominator or denominator to numerator. As an example, in this first problem, we have x to the negative third. We can never have a negative exponent in my simplified answer. X to the negative third is really x to the negative third over 1. So the way to remove a negative exponent is to move that term, in this case just the x, just that base that negative exponent applies, from, in this case, the numerator to the denominator. After doing that, moving the base, that allows me to remove the negative. Now, this is also really 1x to the negative third over 1. So, I have a 1 in my numerator. That's my simplified response. Okay. In this example off on the right-hand side, my negative exponent is in my denominator. So, if it's in my denominator, it has to move to my numerator. The x goes to the numerator, my negative goes away, and it just becomes a positive 4 exponent. This 7 does not have a negative exponent. It can stay in my numerator. So this is not a matter of just taking the reciprocal of my fraction every time I have a negative. It's only moving the base that has the negative exponent. So what's in my denominator now? Well, just like in the first problem, there really is a 1 here. So I have a 1 in my denominator. I don't need to write that. I can just write this as 7x to the fourth, moving my x to my numerator. My denominator is 1. I don't need to write that. And be careful in problems like this as well, because once again, I have my negative exponent, but it's applying only to x. I have no parentheses in this problem. That means the 2 does not move to my denominator. The 2 is not being applied, or the negative exponent is not being applied to the 2. The 2 as a base stays. The x moves. Because I moved it, I can make my exponent positive. When I have an entire set of parentheses raised to a negative power, that is the only time I can take my reciprocal of my fraction. Especially if it's a negative 1, because really what I'm saying here is that the negative allows me to flip my fraction. It would still be in parentheses but raised to the first power, and really anything raised to the first power doesn't change. That's how we can keep our answer just as the flipped, or just as the reciprocal, that flipped fraction. Using these examples, go ahead and try numbers 1, 2, and 3 below. Hit pause, try those 3 problems, then unpause. We'll check those before moving on to the rest. And let's check our answers. In number 1, the negative exponent is really only applying to the b. That means the b has to move to the denominator, make the exponent of 4 positive. The g was already positive. It does not move. It stays in my numerator. In number 2, the only negative exponent is x to the negative second. That gets moved to my denominator. The 2 stays. The 3 stays. Y to the 8th stays. None of those had negative exponents. Just move x to the second down. The 2 becomes positive because I switched numerator to denominator. 3 is a similar idea. The negative 12 exponent applies only to the c. That gets moved to my numerator. P to the 6th and 12 stay where they were. Now, go ahead and try numbers 4 through 6. So unpause and try these last 3 problems, please. So I showed a second step here for number 4 because I want you to focus on the fact that 10 and 20 are really a fraction 10 over 20. And we have to treat that as a fraction, which means I have to simplify that fraction. When I simplify 10 over 20, I get 1 over 2. If you need to put that in your calculator and do a math frac, then go ahead and do that. But that's why I have a 2 in my denominator in my final answer. That 1 is in my numerator, and if I write it there, it's still correct. But I don't need it there to get the right answer. The variables I treat separately. The x goes to my denominator because it's a -7. The z goes to my numerator because it's a -1. Again, I can write the 1 here if I want, but I don't need to. The y to the 13th was in the numerator. It stays. It was not a negative exponent. Number 5 was similar to number 1 and similar to one of our examples. The -4 exponent applies only to x, so the 5 stays in the numerator. X to the 4th goes to the denominator. And number 6, this goes to my numerator. My denominator is technically 1, but like in our example up in the box above, I do not need that denominator. After watching this video, working on these practice problems, you're ready to go ahead and give a try to the quiz for negative exponents.